All right. So writing a polynomial, you're going to get the function y equals, and then it's a times x minus whatever your 0 is. So my first one is negative 2 times x minus my next 0 times x minus my next 0. Now, if it crosses, I'm going to leave my degree to be odd. If it bounces, I'm going to make my degree even. So it crosses here and crosses here, so I'm going to leave it odd. It bounces here, so I'm going to make that 0 even. So now simplifying that, I'm going to get y equals a times x plus 2 times x squared times x minus 1. Now I need to find what a is. And the way that we find a is we pick another point on the graph. Now the only other point on this graph that's nice and available for us is going to be this one right here, which is negative 1, 4. So I'm going to plug in negative 1 for my x and 4 for my y. So a times, this is 1 times negative 2 equals 4. So this is all negative 2, so divide by negative 2, you're going to get a equals negative 2. So then you can write it as y equals negative 2 times x plus 2 times x squared times x minus 1. Let's look at number 3. So y equals a times, we have negative 1, so x minus negative 1, and then I have x minus 0, and then I have 2, so x minus 2. Now if it crosses, my degree would be odd, so 1, 1, and then that bounces at 2, so my degree is 2. So just cleaning it up. Now to find a, we just pick a point, and it looks like this is the only one that's available to us. So that's, 1, negative 4. So negative 4 equals a times 1 plus 1 times 1 times 1 minus 2 squared. So that's 2 times 1 times negative 1 squared, which is 1. So negative 4 equals 2a. Divide by 2, a equals negative 2. Just happens that a is negative 2 for these. So y equals negative 2 times x plus 1 times x minus 2 squared. Now, you could also say it like this. And I could have done the same thing where I take the x squared and I could have put it in front here. It's all fine. Now solving logs, or solving exponential equations that have different bases with logs. So because I can't make the base the same, you're going to convert it into a logarithmic equation, which then allows you to move the exponent to the front, distributing the log 3. Actually, instead of distributing the log 3, why not just divide by it? So then you get x plus 1 equals log 5 over log 3. Subtract 1. X equals log 5 over log 3 minus 1. Looking at number 6, convert it into a log. Now I can move the exponent to the front. Divide by log 5. Subtract the 2. So finding the solution of these, so those are going to be where the shaded region intersects. So graphing this, x minus 3 it doesn't have a equal to sign, so I have to draw a dotted. So there's my graph. I had a horizontal shift of 3. Now if I were to pick a point to shade, if I plugged in 0, 0, is 0 less than or equal to 0 minus 3? So that's true. So I'm just going to, okay, so that side is being shaded. And then for this one right here, y is less than or equal to x minus 3 plus 4. So x minus 3 plus 4. Now if I were to pick a point, let's say 0, 0. 0 is less than or equal to 0 minus 3 squared plus 4. That's 9 plus 4, which is 13. That's true. So all of this is true. This is where it overlaps. And so this is where you're going to shade it. So that darkened region, this is what's